So f of x, the function f of x equals the square root of x minus 2, with x is a member set of reals and x is greater than or equal to 2. State the range of the f of x. So the range is the output values, but often these questions are best begun by sketching. So hopefully you know the square root of x looks, something like that kind of shape. Yeah, it's like the quadratic graph on its side. And now then, when we subtract the 2 from it, we know that it's going to move 2 to the right. So we've got a graph that looks like that. Y equals, or f of x equals the square root of x minus 2. And this value here would be 2. So the range, the outputs, once now we know what we're looking at, is equal to f of x is a member of the set of reals. And that's it. Okay, part B. Find the function f inverse of x and state its domain and range. So let y equal the square root of x minus 2, and we should know now that the domain of the inverse function is the same as the range of the original function. So the range is the y values and the domain are the x values. So if the domain of the inverse function is equal to the range of the original function, we can interchange the x and y. So our inverse, we interchange the x and the y and then make y the subject. So inverse, interchange x and y and make y the subject. So we get x squared equals y minus 2, so y equals x squared plus 2. So writing it in the proper form, f inverse of x, because we were given that notation, is equal to x squared plus 2. Its domain will be the range of the original function, so x is a member of the set of reals, and the range has got to be the same as the domain of the original function, using the same logic as before, because range goes to domain, and therefore domain goes to the range. So the range of f inverse of x is the domain of the original function. So f of x is a member of the set of reals, and f of x is greater than or equal to 2. So we've matched the range of the inverse function. Perhaps I should have said f inverse of x and f inverse of x on there. So the range there was equal to the domain of the original function, and the domain of the inverse function, the inputs, is equal to the range of f of x. Sketch f of x and f inverse of x and the line y equals x. So part C, we've got y equals x squared plus 2, and we've got, so that was at 2, not very well drawn here, sorry, and similarly here 2. So this was y equals f inverse of x, this is y equals f of x, and y equals x is the mirror, or sort of the mirror line, if you like. One reflects to give the other, even if it doesn't really look like it on my diagram.